Hi, welcome to Pro Talk Academy. If you're here to subscribe to our channel, please do so, and also turn on the notification icon in order to receive updates on our new videos. My name is Engineer Buna Nnamdi. Today we will look at the centroid of a bent wire. Consider a bent wire. Here we have a bent wire with a dimension. You can see the various dimensions are provided here. AB, which is 40 millimeter, BC, which is 120 millimeter, CD is 100 millimeter, DE is 40 millimeter. This is not 400, rather it is 40. So let's make the correction. This is 40 millimeter. So this is 40 millimeter. So we wipe out that. So what we have here is 40 millimeter. So we have 40 millimeter. So this is off. So not 400 millimeter. So and EF is 20 millimeter. So let us write out our members. These are, I'll call them items. These are the items, and the items are AB, and we have BC, we have CD, we have DE, we have EF. So accordingly, AB, BC, CD, DE, EF. So the next thing we have to write out here is the dimensions, because we don't have a thickness. No thickness was given to us, so our thickness is equal to 0. So it wasn't given to us, it's not given. So here we have L, which is the member in millimeter. So the next thing we need to have here is the X, and the next thing we'll have here is X or LX. Remember, this will be also in millimeter or millimeter square. Then this will be Y, and this will be LY in millimeter square. So what we'll have here next is our AB is 40, our BC is 120, you can see it here, 120, our CD is 100, our DE is 40, and our EF is 20. So we have 20. So these are the dimensions. We don't have any thickness, so no area will be involved. So the next thing we need to consider is centroidal distance of each member of the bent wire in the x-axis. So this is the x-axis, and this is the y-axis. So these are y-axis. Along this direction is the y-axis. So from here is the x-axis, from this direction is the y-axis. So the first thing we need to consider here, our first member, is AB. So each distance, centroidal distance, is half from the x-axis, because we are considering both from x and y. We are considering this point at 0 point here. So between here and half of this member is 40 over 2. So we'll have 40 over 2, which is equal to 20. So which is still in millimeter. This is still in millimeter, while this is still in millimeter. So they are millimeters, not meter. So they are millimeters. So the next one we need to consider is BC. BC does not have any perpendicular distance, or since the member contains no thickness, it means its distance, centroidal distance from X, is directly on at the point of 0, so it will be equal to 0. Then CD, its own centroidal distance will be half from here to here, which is half of 100. This will be equal to 100 over 2, which is equal to 50. So we'll have 50. Then the next thing we need to consider is DE, this. So its own centroidal distance is the whole of this distance, so it's 100. We have 100 millimeter. Then we have EF. EF, its centroidal distance will be half of this 20 plus 100 minus 20. So it's going to be 20 over 2 plus 100 minus 20, the remainder of this. 100 minus 20 is 80. So what we have here is 20 divided by 2 is 10 plus 80. This will be equal to 90. So what we have here is 90. So LX will be product of what we have here and here. So we have 20 by 40. This will give us the 20 by 40. We multiply LX. So what we have here is 20 by 40. So let me use the calculator. 40 by 20, which is 800. So we have here, we have 800. So the next one we need to consider is 0 by 120 is 0. We have 50 by 100. This is 5,000. We have 100 by 40, which is 4,000. We have 90 by 20, which is 1,800. So we'll consider the distance along y-axis, centroidal distance along y-axis. So for AB is lying directly on the x-axis. So here it does not have, and is aligned at the point of 0. So it doesn't have any perpendicular distance. So it will be 0, since the bent wire has no thickness. So the next one we need to consider is, we consider the second member, which is BC. So its distance will be half of this, which is 120 divided by 2 over 2, and this will be 60. So the next one we need to consider is CD. CD, its own perpendicular distance will be the whole of this distance, so it's going to be 120. That's the distance. It's going to be 120, not 1,200. It's going to be 120. So 120. So the next thing we have to consider is DE. DE, its own perpendicular distance from here, or centroidal distance will be, its own centroidal distance will be DE over 2 plus 120 minus DE. So it's going to be 40 over 2 plus 120 minus 40 is 80 plus 80. So this will be equal to 100. 100, because we have 40 over 2 is 20 plus 80, which is 100. Then the last one we have to consider is EF. EF, the dimension is 20, and its own distance from here is 120 minus 40. So it's going to be 120 minus 40 is 80. So it's 80, because from here to here is the whole of this minus this portion, 40, which is 80. So what we now need to do is to multiply our perpendicular, the centroidal distance, by the overall length of the member, which is Ly. So this is 40 by 0, we have 0. Here we have 60 by 120, we have 60 by 120 by 60, we have 7,200. So we have 7,200 here. Then the next one is 120 by 100, which is 12,000. 120 by 100, this will be 12,000. We write out 12,000. So I have 12,000. Then the next one is 100 by 40, which is 4,000. Then we have 80 by 20, which is 1,600. So the next thing we need to sum now, we need to get, because we have x bar is equal to summation of lx over summation of l. Y bar will be equal to summation of ly over summation of l. So for us to find this, we need to sum the whole of this to have our summation of l. We have to sum the whole of this to have our summation of lx, and we have to sum the whole of this to have our summation of ly. So what is our summation of l? We have 40 plus 120, which is 160, plus 100, which is 260, plus 40, 300, 320. So we'll write this as 320 millimeter. Then we sum this as, this very one will be 800 plus 5,000 plus 4,000 plus 1,800. This will be 11,600. That's what we have, 11,600 millimeter squared. So here we have, this will be the same thing as 7,200 plus we have 7,200 plus 12,000 plus 4,000, this 4,000 plus the last one, which is 1,600 plus 1,600. So what we have is 24,800. So here our summation of lx over summation of l will be 11,600 over 320, which is our summation of l. So this will be equal to 24,800 over this, which is 320. So our x bar is equal to 11,600 divided by 320. This is equal to 36. This is equal to 36.25 millimeter. While our y bar will be equal to 24,800 divided by 320. This is equal to 77.5 millimeter. So millimeter, that's what we have here. So we have our x bar is 36.25 millimeter. So here we have 40 millimeter. So it should be close to this. So if we trace along x bar, we trace it and go up, or we use, okay, let's use a colored, another color. Let's try using this. Okay, let's say this is the portion of 36 points that, and along 36.25 along the y-axis we're looking at 77.5. half of this member is 60, so 77.5 should be somewhere here within this region. So we are considering something within this region. So this is the position of our centroid of the member. So centroid, the CG, this is the CG of this member. It lies at here. If we can write out, we have 77.5 millimeter, and from here we have 36.25 millimeter. So from this point and from this point, so let me use another color to shade it up. This is another color. So I have here, and see, this is where the point we are considering. So, and this is the CG of this shape. So viewers, this is where we draw the curtains on today's lecture on the centroid of a bent wire. If you're yet to subscribe to our channel, please do so by hitting the subscribe button. You can also click the notification icon in order to receive new videos from us. If see you in the next lecture, the second example on the centroid of a bent of shapes. So today is the centroid of a bent wire. In the next lecture, we'll talk about centroid of other given shapes. So my name is Engineer Namdi. See you in the next video. Bye for now.